Metamorphic rocks. Rock dough. Rocks do not change form. Did you know that heat can change a rock's form without melting it? To understand how, think of what happens when you bake cookies. You might mix flour, eggs, sugar, and baking powder in a bowl. When you bake the raw dough in a hot oven, the dough changes into cookies. Heat can change rock too. If hot magma or lava comes near rock, the heat can bake the rock. The ingredients in the rock, the minerals, might not melt, but the heat can still change the rock into a new form. Does rock have to melt in order to change form? Explain. What are metamorphic rocks? You may be surprised to learn that heat can change rock like a hot oven changes raw cookie dough. But deep inside Earth, both heat and pressure are much greater than at Earth's surface. When great heat and pressure are applied to rock, the rock can change both its shape and its composition. Any rock that forms from another rock as a result of changes in heat or pressure, or both heat and pressure, is a metamorphic rock. How metamorphic rock forms. Metamorphic rock can form out of igneous, sedimentary, or other metamorphic rock. Many metamorphic rocks are found in mountains or near large masses of igneous rock. Why are metamorphic rocks commonly found in these locations? The answer lies inside Earth. The heat that can change a rock into metamorphic rock can come from pockets of magma. For instance, pockets of magma can rise through the crust. The high temperatures of these pockets can change rock into metamorphic rock. Collisions between Earth's plates can also push rock down toward the heat of the mantle, the layer of hot solid material between Earth's crust and core. Very high pressure can also change rock into a metamorphic rock. For instance, plate collisions cause great pressure to be applied to rocks while mountains are being formed. The pressure can deform or change the physical shape of the rock as shown in Figure 1. Also, the deeper that a rock is buried into the crust, the greater the pressure on that rock. Under very high temperature or pressure, or both, the minerals in a rock can be changed into other minerals. At the same time, the appearance, texture, and crystal structure of the minerals in the rock change. The rock eventually becomes a metamorphic rock. What changed the rock? Make sure your answer explains the rock's current appearance. How metamorphic rocks are classified. While metamorphic rocks are forming, intense heat changes the size and shape of the grains or mineral crystals in the rock. Extreme pressure squeezes rock so that the mineral grains may line up in flat parallel layers. Geologists classify metamorphic rocks according to the arrangement of the grains making up the rocks. Foliated rocks. Metamorphic rocks that have their grains arranged in either parallel layers or bands are said to be foliated. Foliated describes the thin, flat layering found in most metamorphic rocks. For instance, the crystals in granite can be flattened to create the foliated texture of gneiss. Slate is also a common foliated rock. Heat and pressure change the sedimentary rock shale into slate. Slate is basically a denser, more compact version of shale. But as shale changes into slate, the mineral composition of the shale can change. Non-foliated rocks. Some metamorphic rocks are non-foliated. The mineral grains in these rocks are arranged randomly. Marble and quartzite are metamorphic rocks that have a non-foliated texture. Quartzite forms out of quartz sandstone. The weakly cemented quartz particles in the sandstone recrystallize to form a quartzite, which is extremely hard. Quartzite looks smoother than sandstone as shown in Figure 2. Finally, marble usually forms when limestone is subjected to heat and pressure deep beneath the surface. Read the text on this next page. Underline each sentence that describes how one type of rock changes into another type of rock. Great heat and pressure can change one type of rock into another. Label each rock sedimentary, igneous, or metamorphic. Indicate whether the metamorphic rocks are foliated. Then shade the correct arrowhead to show which rock can form from the other rock. How metamorphic rocks are used. Marble and slate are two of the most useful metamorphic rocks. Marble has an even grain, so it can be cut into thin slabs or carved into many shapes, and marble is easy to polish. So architects and sculptors use marble for many statues and buildings, such as the Tower of Pisa. Like marble, slate comes in many colors, including gray, red, and purple. Because it is foliated, slate splits easily into flat pieces. These pieces can be used for roofing, outdoor walkways, and as trim for stone buildings. The metamorphic rocks, marble and slate, are important materials for building and sculpture. Although marble, quartzite, and slate are all metamorphic rocks, they are used in different ways. Look around your school or neighborhood. What examples of metamorphic rock can you find? How is each metamorphic rock used? Write your answers in the notebook at the right. Why are chess pieces sometimes made of marble? Define what is a metamorphic rock. Identify faulty reasoning. Suppose great heat completely melts a certain deposit of rock, which then hardens into a new rock, just as cooling magma hardens into a solid rock. You might think that the new rock is a metamorphic, but it isn't. Why not?